Sorry that went a little long. As with any of my videos, if I'm just rambling, you can fast forward right through me. You don't have to listen to all of the rambling like what I'm doing right now. So the change of base, that's the, I think it's the weirdest one. It's kind of like a property, really, but it's weird. It's, to me, the other one's kind of intuitive. Yeah, I can see that those work, but this one is so strange. I'm saying that whatever base you're using and whatever you're taking the log of, well, you can just pick a different base and then take that different base of a and divide it by the log of the different base of c. It's so strange that you can do that. And I don't, when things are strange, I don't like to just take them at face value and just accept them. I like to see that they're true. Whether I prove it or somebody else convinces me it's true, my heart cannot rest until I'm convinced that it's true. So let's prove this to ourselves, okay? So I'm going to reference a proof that I wrote a while ago, just to help me through here. All right, so let's take a look at log base c of a. It's something, all right? So let's just start off with that easy to believe fact. Log base c of a is equal to y. And we're going to find out what y is. We're going to hope that y is this big thing. We hope to figure that out. Okay, so we're going to take this equation, let's just write it in exponential form, right? So if log base c of a equals y, that means that c to the y is equal to a, right? Because the question over here is, what's the power of c that gives me a? The answer is y. That means that c to the y is equal to a, okay? So c to the y is equal to a. Now, I want to solve for y. Remember, I'm trying to find out what y is. How do we solve for y? Let's see. Well, we don't want y to be in the exponent, okay? So let's pick a different base and take the log of that base of both sides, all right? So let's take the log base b of both sides. All right. And that's totally legal. Like, as long as I do the same thing to both sides, it's okay. You know, this balance, you know, these scales are still balanced because I've just done the same thing to both sides. If both sides were to get 3 out of them, they'd be the same. If they were both to be divided by 7, they'd be the same. If you take the log base b of both sides, they're still the same. They're still equal. Okay. Now, what did we just say in the previous proof, the very last proof of the last video? What was that? That was the power property. The power property says if I have a power of this thing that I'm taking the log of, then it can come down and become the coefficient of this expression. So y times the log base b of c equals log base b of a. Now keep in mind, this whole time what we were saying is that log base c of a is something, it's y. We're trying to find y. Now, can we solve for y? Absolutely. We've got that y times log base b of c is equal to log base b of a. So if I have two things that are multiplied together and I want to separate them, cancel this thing out, then I would divide by that thing. I'm going to divide by the log base b of c. Divide by log base b of c. Y is equal to the log base b of a over the log base b of c. All right, and what was y? Y was log base c of a, so log base c of a is equal to y is equal to log base b of a over log base b of c. Okay, and that's the change of base. If you stuck with me, thank you. I appreciate that. And I will start doing some sample problems now in the next video.